All right, so let's go back, and we did sine. Now let's do cosine and manipulate its values. Again, if we take a look at 3 cosine, we know, let me go to blue, that what we are doing is there's a vertical stretch, right? And what we're doing is we're multiplying by 3. So we're taking all our y values and multiplying by 3. So again, if you go to your cosine graph, right, what are the big 3? Well, as far as x, or big 5, as far as x is concerned, it's all my quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for cosine, we knew it starts at 1 and goes to 0, goes to -1, 0, and +1 to create our classic cosine graph over its first full rotation. And so what we need to do to manipulate it, we're going to take all these y values and multiply them by 3. So here's what my new data table is going to look like. My x coordinates are not changing, right? They're still the big special quadrantal angles, but all my y coordinates are being multiplied by 3. So 1 times 3 is 3, 0 times 3 is 0, -1 times 3 is -3, 0 times 3 is 0, and 1 times 3 is 3. So when it comes to graphing this, right, here's what the graph will look like. So again, breaking things up, scaling things in terms of my big quadrantal angles. And how about, it looks like we're 3 to -3, so I'll go 1, 2, 3, -1, -2, -3, and we can start plotting data. So we have 0, 3, we have pi over 2, 0, we have pi -3, we've got 3 pi over 2, 0, and we got 2 pi 3. And filling in the rest of the details, right, here's the graph of 3 cosine of x. Of course, this is one cycle, right? I should have said that up here. This will just keep on going forever and ever in both directions. We're just doing one cycle, and we can sketch the rest, but I don't want to get into that graph. And if we compared it to cosine, right? Cosine tops out at that, and here, and here, and here, and here. So here's our cosine graph in blue. And so you can really see, right, what we've done is we've stretched the graph out. We've made it elongated. We didn't really change the x values, right, because that's not what's happening with this translation. It's all impacting outputs. We're multiplying them by 3. Okay, and then if, again, quick learner, what happens when I multiply by 1/3? Well, this time what we're going to do is we're going to compress by 1/3, which means I'm going to come to these y values over here, and I'm going to be multiplying them by 1/3. So building that data table, the quadrantal angles are still involved. We're not doing anything with them. And all my y values are being multiplied by 1/3. So 1 times 1/3, oops, I should stay in red. 1/3, 0, -1/3, 0, and 1/3. So when it comes to looking at this graph, again, I'll stay with a nice pi over 2, pi, 3 pi over 2, and 2 pi. And then how about, here's 1, and here's -1, and that would basically be thirds. So we're 0 and 1/3. We are pi over 2, 0. We're pi and -1/3. We're 3 pi over 2 and 0. And we're 2 pi and 1/3. So here in red would be the graph, one cycle anyways, right, of 1/3 cosine of x. And if we compared it to the original one, right, it's 1, 0, -1, 0, 1. So in blue, here's what cosine looks like on one cycle. So again, we've taken that graph and we've compressed it. So here, the amplitude is 1/3, right? The height of the wave, again, the equilibrium is the x-axis. It's 1/3 above it and 1/3 below it, so its amplitude is 1/3. Over here, the amplitude would be equal to 3. So again, there's my equilibrium, and the wave is 3 units above it or 3 units below it, and it keeps bouncing back 3 units above and below as it cycles back and forth. Again, this is just one cycle, right? We're talking about one revolution. These graphs would go on forever and ever and ever right, if we allowed them to. But now that we have one period, we just keep getting the periods as we go along. All right, and so there's amplitude. So again, we've just handled what happens when we take a constant and we multiply it to a of f of x. And there's actually 3 more translations we need to talk about. But we'll do that in some videos coming up.